Welcome to Spring LIB.
Problem, we have been given that there is a block and it starts moving at point A with a speed of 5 meter per second, and this inclined plane is having angle of inclination as 25 degree, and the coefficient of kinetic friction is 0.35. So we need to determine the distance d through which this block will move up the incline, provided that it stops at point B. So as it stops at this point B, its speed will drop to 0 meter per second. So here we can apply the conservation of energy. So the total energy at this point A, that will be just the kinetic energy, and that will be half mv square. And from this total energy, the energy to overcome the friction, that is the friction force, which can be obtained by drawing the free body diagram. So the weight is in the downward direction, and the normal force will be the component of this weight, and that will be mg cos 25 degree. And now we can observe that the friction force, that will be equal to the kinetic friction times the normal force, that's mg cos 25 degree. And this energy is equal to the remaining energy at this point B, which is just the gravitational potential energy, because the object stops at this point, and the gravitational potential energy, that will be equal to, also we need to multiply here with d, because we are talking about the energy required to overcome the friction force. So that will be mg into the vertical height, which will be the component of d in this opposite direction. So we can use simple trigonometry, and that comes out to be d times sine 25 degree. So from here we can cut m from both the sides, and putting the value of v here, we're going to get 25 by 2, that's 12.5, minus 0.3 times cos 25, which is approximately 0.317, and that we multiply with acceleration due to gravity, which is 9.81. So that comes out to be 3.1 d, and that's equal to g times sine 25 degree, which is approximately 4.15 d. So from here we can get the value for d by adding 3.1 with 4.15, and that's 7.25 d. And now we divide this 12.5 with 7.25, and that's going to give us the value for d as 1.7 meters approximately.